Welcome back to my channel Reagent. In this video, I'm going to explain about chemical thermodynamics, types of chemical reactions. As you know that according to chemical thermodynamics, the reactions can be classified into two types, endothermic and exothermic chemical reaction. Now I have come up with the exothermic chemical reaction where burning of hydrocarbon called methane to produce carbon dioxide and water vapor. Enthalpy change for this reaction, burning of methane produces delta H is equal to here, delta H is shown here, delta H value is represented here. Delta H is equal to minus 890.3 kilojoules per mole, means 1 mole of methane undergoes combustion in the presence of oxygen, produces minus 890.3 kilojoules per mole. Here, if you observe the graph, here the graph, so potential energy of the reactants. In this chemical reaction, the reactants are oxygen and the methane. So the here the potential energy taken on y-axis, so and on x-axis, so reaction pathway is taken, or this is progress of the reaction. We say progress of the reaction, progress of reaction this side, and potential energy. The energy barrier between reactants and products here is, that is to be potential energy, we say. Now initially reactants containing higher amount of energy. In case of exothermic chemical reaction, reactants possess a greater amount of energy than reactants of endothermic chemical reaction. So already, reactants having higher amount of energy, just if you provide spark, just if you provide initial amount of energy, so then reaction will be triggered to produce what means the products. Here products are taken, carbon dioxide and water. Carbon dioxide and what are the products, we say. So the energy difference between the reactants and products. So products have less amount of energy, whereas reactants have higher amount of energy, we say. The energy difference between products and the reactants will be delta H is equal to minus 890.3 kilojoules per mole, we say. So here is this reaction is best example for exothermic chemical reaction. Almost all combustion reactions, so comes under exothermic chemical reaction. Exo means outside, energy released. The chemical reaction in which energy is released rather than absorbed. So this is energy profile diagram for the combustion reaction, and the activation, in this case, activation energy is, so activation energy is less in this case. So activation energy is less, so and most of the chemical reactions have less amount of activation energy. So hence the most of these exothermic chemical reactions are spontaneous reactions, we say, spontaneous reactions, where endothermic chemical reactions are non-spontaneous chemical reactions. So and just if you provide small amount of energy spark, the chemical reactions can be triggered, and most of the reactions are spontaneous reactions, we say, exothermic chemical reactions. Thank you.